Now let's take a look at the SonarQube learning repository. I set up the SonarQube learning repository for us to understand how SonarQube works. So once you're in my GitHub, you come to SonarQube learning repo. You come to SonarQube learning repo. Now, once you're in SonarQube learning repo, this repository basically I set it up to give you a more detailed understanding of what SonarQube is. Now, it gives you a basic introduction. SonarQube is an open source platform for continuous code quality and security analysis. So once you set up SonarQube, you actually basically want to do code quality and security analysis. And these are some key features which we are going to see as far as SonarQube is concerned. We have comprehensive code analysis, where it detects issues like bugs, vulnerabilities, code smells, and duplications. We also have quality gate, where you can enforce some configuration threshold that code must meet before you can actually merge. We have multi-language support. We'll see that it can support languages like Java, Python, JavaScript, C++. Then we equally have security scanning, where we can identify security vulnerabilities, technical depth, and a lot more. So these are some key features which SonarQube has. Once you set up a SonarQube server, you can perform comprehensive code analysis. You can perform, or you can enable or set up quality gates. You can have support for multiple languages as far as scanning is concerned. You can do security scanning and all that. Now, what are some common use cases of SonarQube? You can use SonarQube for code quality management. You can use SonarQube for security auditing and for technical depth tracking. So when you come to this repository basically gives you a more detailed understanding of what you can use SonarQube for. Now, how do you integrate SonarQube maybe to a CI/CD pipeline? If you set up a CI/CD pipeline with something like Jenkins, now the most important thing is you can enable SonarQube integration with tools like Maven, where in your pom.xml file, remember we have our pom.xml file. If you come back to our practice Maven learning project, which we have been working on for both Maven and SonarQube, and then you open this Java code, you will see the pom.xml file. This pom.xml file is a file which we explain that we can have dependencies, libraries, and all the like. Once you're in your pom.xml file, you can configure the usage of SonarQube here in your pom.xml file. So if you come back to your basically in a repo, this is how you can set it up. You can add SonarQube to your pom.xml file to set up a code to set up SonarQube analysis in the Maven project. So this is basically the code which you can use to set up such analysis in your pom.xml file. Now, equally, you could set up these servers assuming that you have a settings.xml file which you can equally use to perform your code analysis or your code checking. Now, if you come back to our project repository, yes, our setting.xml file, and if you come to our setting.xml file, you will see that we have this given configuration here, where we have a configuration to set up the SonarQube given host. Basically, you specifying which server SonarQube runs on. So if you come here, this is where you actually modify the credentials or the settings to match that of your SonarQube server. Now, basically, as far as when you have SonarQube set up, you can then run the Maven deploy command, and with the Maven deploy command, it's basically going to run the same set of tests. We're going to run static code analysis on whatever configuration code which you have. Now, if you were to integrate SonarQube to a CI/CD pipeline like Jenkins, basically you integrate a stage where SonarQube will perform an analysis. Now, this is basically how you set up SonarQube. You use environment variable with SonarQube environment variable, where you've installed the SonarQube plugin, and then you run now the SonarQube command mvn sonar. So this is basically how you can integrate SonarQube with Jenkins. You can equally go ahead to perform the same integration with GitHub Actions. Assuming you are setting up CI/CD integration with GitHub Actions, you can set up a SonarQube integration with GitHub Actions, where you run this job to perform the same code analysis on your code, as well as GitLab CI and even Microsoft Azure DevOps. So these are some basic examples on how you can integrate SonarQube or static code analysis. Now, for our given use case, this is the implementation which we are going to be doing. we already have implemented in the previous use cases. We've done the Maven stage where we use Maven to perform the build. We've equally stored our artifacts to Nexus. Now we are going to be integrating a stage in between Maven and Nexus repository. Ideally, you need to perform a SonarQube analysis before you can even store such artifacts in a repository manager. So we are going to be setting up SonarQube server that will perform bug checks, perform vulnerability scanning, search for code smells and duplications. Once you set the SonarQube server, the moment you upload your code to your given Maven server, you will use SonarQube to perform static code analysis, and if the code passes your code analysis, then you can run a Maven deploy to push the code to your repository management with Nexus. So this is basically how Maven, SonarQube, and Nexus work hand in hand, where the developer pushes the code to GitHub, the code is automatically cloned to the Maven server. You run the SonarQube analysis code on the Maven server to check for vulnerabilities on the code base, which has been pushed into the Maven server. And if all vulnerability checks are passed, then you can run a Maven deploy to deploy the code to your Nexus repository. So these are the basic steps on integrating Maven, SonarQube, Nexus with GitHub as far as the build stages are concerned for your Java-based web application. Now, back to our repository, there's some other configuration which you must take note of. In this repository, I equally have the installation setup. So here's an installation setups. We have the Maven installation, which we've already done in our previous module. We equally have Nexus installation, which we've done in our previous module. Now, the most important is for us to install SonarQube installation, which we'll be doing. Now, the most important is for us to install SonarQube. So we'll be doing SonarQube installation. And if you can look at these user data, we are basically using the apt-get. So we are going to be using an Ubuntu image for us to install SonarQube on that server. So we'll be installing SonarQube in an Ubuntu server. And again, you have the setup configuration script for Nexus in this same repository, as well as you have the installation script for Maven, how to install Maven on Amazon Linux 2 instance. So we are going to be going right away to install SonarQube based on this installation. We just copy this user data and then we'll be installing SonarQube on our SonarQube server. So for us to set up the repository, so for us to set up the project environment, this is basically the architecture which we are going to be following. And based on our architecture, we are going to be using the tools Git, GitHub, Maven, SonarQube, Nexus, and of course EC2 instance. So these are the basic configuration commands which you need to configure the various environments. This is how you need to configure your environment. We've already done these steps. We've already created our Maven practice Maven learning repo. We've equally set up our Maven server already. And then we've equally set up our Nexus and connected to our Nexus repository. So what we are going to be doing is for us to set up our Prometheus. Now you should install create an Ubuntu 22.04, not 20.04, 22.04. Use the instance type T2 medium and then security group port 9000 open to port 9000 and port 22. And then you select your key pair and you can use the installation script here, the SonarQube installation script, and then you launch the instance. Take note, you should run this on Ubuntu 22.04. So these are the basic configurations which you need to run this given SonarQube project. So let's go ahead to set up our SonarQube server. Remember, we already have our Maven server up and running, and we equally have our Nexus server up and running. We are going to be setting up our SonarQube server. One thing worth noting is SonarQube runs on a given port. Just like we had Maven, we're able to connect to our Maven server on port 22. And then on our Nexus server, we're able to connect to our Nexus server on port 8081. So let's first begin by searching the port which we can use for our SonarQube server. So for us to do that, let's search SonarQube port number. So you can search SonarQube port number. So you see SonarQube default port is port 9000. So officially, if you are to set up SonarQube, you can use SonarQube. The default port is port 9000. They say it's configurable, meaning if you want to change this port, you can change the port per your configurations. But I'll always recommend you set up SonarQube using the default port. So for us to set up SonarQube, as on the user data which I explained earlier, our user data has sudo apt-get, meaning we are going to be using an Ubuntu image. So on the Amazon EC2 console, we are going to be using an Ubuntu image to set up SonarQube. And if you look at the user data here, on line 52 of our code, you can see sonar.web.port specifying that we are going to be listening to port 9000 on our server side, which is the same like the port number which we have when you configure SonarQube. So we will just basically copy this user data. Basically, the user data, as you can see, gets some packages. It gets the OpenJDK 11, which is a Java package needed to run SonarQube, and then we get the PostgreSQL database, and then you equally enable the PostgreSQL database service, and these are all configurations for the PostgreSQL database which is used by SonarQube. And then you make a directory on the server for SonarQube. You set into a directory. You get some packages. Well, you get the SonarQube package, and then you unzip this package. And basically, these are just SonarQube commands. You create a SonarQube user, SonarQube, Sonar, and then admin. And then once you've done these basic configurations, you can enable SonarQube service, you can start the SonarQube service, and possibly you can reboot the system. So this is just a basic configuration on how to install SonarQube. If you're wondering how this SonarQube user data is all about, you can equally search for SonarQube. You can equally search for SonarQube installation user data. Is actually available on the internet, so you can search for SonarQube installation user data. These are official documentations on how to install the SonarQube server. You can look at this documentation and run the commands one at a time, but we are going to be using this user data which I've put together in this repository. So for us to do that, first we copy the user data. I'll copy the user data. You select here on our GitHub, you can copy the user data, and if you come to our EC2 console, we select launch instance. Once we select launch instance, we are going to give the instance name SonarQube server. That's for the instance name. We give the instance name SonarQube server. Then we are going to be using an Ubuntu image as per our user data. We are going to be using an Ubuntu image, and we'll specify the Ubuntu 22.04, which is equally free tier. The user data was written in consideration of Ubuntu 22.04. You confirm the changes, and then for the instance type, you can select the T2 medium. You can select T2 medium for the instance type, just for our server to be a little bit faster. And then you can select the port, and then you can select the user. And then you can select the key pair which you have access to per your configuration. You can select the key pair which you have access to. Now, for the network settings, which is most important, you click on edit. You edit network settings. You can enable or you can allow the default. You can allow the default networking settings. I'm allowing the default networking settings because I want it to, well, I'm basically setting it up in a public subnet. So you should equally have your SonarQube server running in a public subnet. And we have auto enable public IP enabled, or auto assign. And we have auto assign public IP enabled. Now we are going to be creating a new security group. So call this security group Sonar Learning SG. You can give it the same description, Sonar Learning SG. Now you want to also allow this default port 22 should, in case we have some issues that we want to troubleshoot our server, you SSH to the server using port 22. But based on our previous search, SonarQube runs on port 9000, so you must have a security group rule open to port 9000. So I'll click on add security group rule. I'll allow it at custom TCP, and I'll put the port range 9000. And then for the source type, I'll allow, because we are doing training, by default, I'll allow it from anywhere, but ideally you could actually set up specific sources based on your project requirement. Because this is a training video, we allow source from anywhere. Now, you're allowing the network configurations as they are default. you have the last thing, which is most important. We need to click on advanced details. When you click on advanced details, you come below, you see a space where you can put the user data. You see a space where you can put the user data. You can come back if you've not yet copied the user data. Come back to my repository, come under installations, click on SonarQube install.sh. You have access to the user data here. You can copy this user data. We copy the user data, you come back to launch instance, and then you paste this user data. So basically, we are going to be launching the instance with this user data. A brief recap of the steps which you've completed. First, we give the SonarQube server a name, SonarQube Learning Server, or well, SonarQube Server. We select Ubuntu 22.04, and then we select the instance type T2.medium, and then we select our key pair, should in case we have issues with our SonarQube server which we want to troubleshoot. And then we are using our default network settings in a public subnet, and we are creating a new security group, Sonar Learning Security Group. We equally have port 22 open in this security group for us to be able to SSH to the server to troubleshoot, should in case our server has issues. And then we equally have port 9000 open. Remember, port 9000 is a default port which SonarQube uses. And then if you come back, we equally had to add a user data. So we add a user data under advanced settings. We add a user data to install SonarQube. So once you set this up, this basic summary, one instance, we're using the canonical Ubuntu 22.04 T2 medium instance in a new security group. Once you have all these configurations, you click on launch instance. Say please wait while we launch your instance, so you do not have to get, or well, you don't need to get out of this page. So our instance has successfully initiated launch, or has successfully been launched. So you see successfully initiated launch of instance. If you click here, it will take us to the particular instance which we've launched. And for this, we have this is the instance ID as SonarQube server. So you make sure to click on this checkbox. When you click on this checkbox, it'll give you more details about your instance. You can see the details, the instance ID, the instance public IP, the instance private IP. You can see the instance is in a pending state, meaning it is not yet running. And then you can equally check out some more details as far as this instance is concerned, like instance security, basically what security group this instance is running. If you click on instance security, you see the security group, the Sonar Learning Security Group which we created, and basically you see the security group has two ports, port 9000 for SonarQube and port 22 for your inbound roles, and then for our outbound roles we still have default security groups. Actually, once you enable inbound, you automatically provision the outbound for all traffic because security groups are stateful. Now if you refresh, our instance state basically has moved from running to from pending to running. We have the instance status check is still initializing. What you can do is, while it's initializing, you can copy the instance public IP. Copy the instance public IP. You open a new tab on your browser. Once you open a new tab on your browser, you paste the instance public IP. You put colon, and then you put 9000, specifying the specific SonarQube port. So you put your public IP. Here's our public IP. You put colon, and then you specify the port number of SonarQube, which is 9000. So once you have this, you can see come back to your instance to verify it has passed a 212 check. So you can see verify if your instance has passed a 212 check. You see if you reload, it tells you the instance is still initializing. Just to confirm, you can put, once you put these details on this new browser, if you hit enter, if it shows you this telling you the site is not secure, you can click on continue to site. Now the instance has not probably finished installing, so let's come back to our instance and check the instance health. It's still initializing. So if you check the instance basically has still not passed the 212 check. For us to ensure if you can access the server, you reload the server again. Once you reload, you'll now see our instance SonarQube server has passed the 212 check. Now, once the SonarQube server has passed the 212 check, for you to access the SonarQube server, you copy the public IP of the SonarQube server, you open a new tab, you paste in a new tab, and then you put colon 900 and you hit enter. So if you do colon 900 and you hit enter, you should log into, it should take you into this SonarQube landing page. Like I explained earlier, SonarQube basically is for continuous code quality analysis. You can check for bugs, you can check for vulnerabilities, you can check for code smells, you can check for security hotspots. We have not created any project in our SonarQube server, so that's why you see the projects here is 0. And then we have SonarQube has multi-language support. 20 plus programming languages are supported by SonarQube. So it supports Java, C++, and C Sharp, COBOL, HTML, JavaScript, TypeScript, Object-C, XML, Swift. So all these are languages that are supported by SonarQube. And then for you can equally do reliability, where you can check for bugs. For security, you can check for vulnerabilities and security hotspots. And then for maintainability, you can check for code smells. This basically are some configurations or some setups which you can use your SonarQube server for. Now we have our SonarQube setup. Let's do the basic configurations on our SonarQube server. So for us to get started, we begin by logging into our SonarQube server. So you click on login. This should log you into your SonarQube server. So the default password and username for SonarQube is admin. So I type admin, and then the password, I type the same admin, everything lowercase. So you do admin lowercase, and then you pass that as the same password, admin lowercase. So once you do this, you click on login, and this should log you into the SonarQube server. Once you're logged into the SonarQube server, you can see here your various SonarQube projects. If you have any current projects, based on the projects, you can tell you if your project passed or if your project failed. You can use these basic filters to check for past projects as well as for failed projects. Now you can equally check for vulnerability, like bugs, either some bugs in your code. You can equally check for security vulnerabilities in your given project. You can equally check for security hotspots, code smells, and duplications and all of that. So this is for a given project. Now you can equally have issues, assuming you've run your project and there are some issues with respect to your code or with respect to your project. You can see all those issues once you click on issues. And then if you have to set up some rules that will enable, or well, these rules basically are the configurations which SonarQube has to perform all the various scanning. So based on the programming language, there are already some default rules. If you are running a Java application, for example, if I click Java, these are rules which SonarQube already has. That means if you do not pass this, or if your code does not have these configurations, it means the project will fail. I give you a simple example. SonarQube says dot equals this should not be used to test the value of atomic classes. So this will report is you will report this as a bug. So this is a bug. If you see, this is a bug detection rule. Now equal plus should not be used instead of plus equal. So it will detect this as a bug, and so on. If you come again here, clone should not be overridden. So this is a code smell detection rule. This rule will detect a code smell. And then if you come to active mcure connection factory should not be vulnerable to malicious code deserialization. This is a vulnerability detection rule. So based on the Java application, these are different rules which SonarQube already has, which will be testing or which will be running on any given Java code which you pass through, or on any given code which you scan using SonarQube. The same thing for Python. If you have a Python project and you want to run a scan on the project for vulnerabilities, for code smells, security hotspots, these are some of the hotspots these are some of the rules which will run on the given code base. For example, access of non-existent member. Now for each of these rules, you can actually click on it and get more details on a use case, on common use case. So they give you, for example, this is a non-compliant example of how this can be defined in a given code block. And then contrary to, this is how you can actually, this is a compliant way of defining this. If you come back to our Java, for example, if you take equal plus equal to should not be used instead of that. So they give you, this is a non-compliant example. You define an integer, target equals -5, num equals to this. They tell you that this is a non-compliant example, and this is a compliant example. So if you did this first non-compliant example in your code base and you run SonarQube scan, you will fail until you have a much compliant definition of that given code base, just like this. So this is what will automatically run on the code base without the need of a senior developer to run the code or to run the checks manually, or to go through a given code base to be checking if they are compliant with respect to plus equal to, or if they are compliant to all these rules. So SonarQube will automatically check all these rules on behalf of a lead developer without necessarily going into the code manually to perform all those checks. So assuming we equally have quality profiles. Quality profiles basically are the ways through which you want to set up the tightening or the strengthening of your code base with respect to the given rules. So if you have a set of rules that you want to combine together, you can create them as profiles. So we have quality profiles, a collection of rules to apply during an analysis. So if you have some specific rules that you want to apply when you're running the analysis on your code, you can create a quality profile. As well as we have quality gates. Quality gates now go a lot more detailedly to specify more conditions which will be executed in your code. For example, these are conditions every time a developer pushes a new code. You want to maybe check the coverage, code coverage. What is the code coverage? You want to check the percentage of duplicated lines in your code. You want to check maintainability rating. You want to check reliability rating. You want to check security hotspots and security rating. So these are basic configurations which you can have. You can click on create if you are trying to create a new quality gate, and you can give the quality gate a name, and then you now, let's just take for example test quality gate, test quality gate, test quality gate. Now once you click on create this test quality gate and you save it, it will now give you the condition. It will now give you the ability to add different conditions. So you can add different conditions. Do you want these conditions on a new code which is pushed into a given project code base, or do you want to run it on the overall code? And now when does the quality gate fail? These are different conditions. Is it based on the lines coverage, or the lines to cover on skipped unit tests, and so on? So these are different conditions which you can use to set up your quality gate based on security review, size, a lot more. These are all basic conditions which you can use to set up your quality gate. So I'll cancel this. And then the last thing which we have is the administration. Administration is very important. This is where you manage your SonarQube server. Assuming you want to integrate SonarQube with other third-party tools, you do that at the level of your administration. Now we are going to be using subsequently, we are going to be integrating SonarQube with Jenkins. And for such an integration between SonarQube and Jenkins, you can come to configuration here and you can set up webhooks. So if you have to set up a webhook between SonarQube and Jenkins, you set up that webhook at this stage where you define. They say webhooks are used to notify external services when a project analysis is done. So if you perform SonarQube analysis on a given project code base and you maybe want to inform Jenkins that the analysis is complete, or you want to inform another tool on the completion of a given analysis, you can use SonarQube. So SonarQube webhooks enable that. Basically, to set up a webhook, you can click on create and it should automatically create a webhook. So we are going to go back to projects. We'll begin by creating our SonarQube project. So I'll click on create new project. Now I'll give this project the name Java. Let me give it the name Java Web App. Java Web App, maybe project. You can give the project the name Java Web App project. So this should create a project. Now you click on setup. Now once you're setting up the Java Web App project, you can still give the name of the token. You can say Java token. When you give the name Java token, you click on generate. Once you generate this token, you click on continue. Now based on the analysis, they ask you which type of project are you running analysis on. So you're running the analysis on what? Are you running the analysis on the Java project, on the C# project, or on Python, PHP, Go, JavaScript, or TypeScript? Which kind of project are you running on? So what is your project's main language? If you come back to our project, our practice Maven learning in a VS Code, our project is a Java application. We are running a Java application. If you click here, src main Java demo application.java, this is a Java application we are running. So our project is a Java project. So we come back to our SonarQube and we click on Java because we are running a Java project. Now they'll ask, you are running or you are developing primarily in Java. What is your build technology? What is your build technology? What are you using to build the Java project? Remember, we've set up Maven to perform the build. So we are using Maven to perform the build. You come back to instances and you click on running. We had configured this Maven server to perform our deployment. So they ask, so SonarQube asks, what is your build technology? So I'll select Maven. Maven is my build technology. Now, once you select Maven, SonarQube gives you this code. Take note, this code is particular to your given server. So execute the scanner for SonarQube from your computer. So running a SonarQube analysis with Maven is straightforward. You just need to run the following command on your project folder. So if you go into the project folder and you run this command in your project folder, it will automatically perform a scan on your code. So we are going to do that right away. So if you copy this token and run on your Maven server, you're definitely going to have an automatic analysis being performed on your code. So in our next module, we are going to be performing the code analysis. But before we get into our next module, let's copy this code. So you copy this code, you come back to your project base, you have this your learning repo. So what you can do is you create a new file. You can call this file you can call it rough.txt. You call it rough.txt and then you paste this code. We are pasting this code here because we don't want to lose the code. So we have Maven, Sonar. This is basically what is used for us to perform the analysis. So instead of us using, this is the public IP of your SonarQube server. Instead of you using the public IP of your SonarQube server, we'll come back to our instances. Remember, this is the IP address 3.236.36.125, which corresponds to the same IP of your SonarQube server. And if you come back to our instances, if you look here, if you select our SonarQube server, this is the public IP. But we are going to replace, so I'll copy this. We are going to replace this public IP with the private IP of our SonarQube server. So we have replaced the public IP with the private IP of our SonarQube server. Now let's go ahead to run the code analysis on our Maven project. So they say running SonarQube analysis with Maven is straightforward. You just need to run the following command in your projects folder. So for us to get started, let's log into our Maven server. We already set up Maven in our previous modules. So I'll select the Maven server. I'll click on connect. If you do not have a Maven server, set up a Maven server. Use the previous module to set up a Maven server because we need that for this given step. Once you click on connect, you copy the credentials for this given Maven server. I'll come to my terminal and then I will cd into the directory that has my key pair. So if I do pwd, my key pair is currently on my desktop. I'll be running the ssh command here on my desktop, which has my key pair. So I'll paste the command to ssh to my Maven server. Once I hit enter, it'll give me the configuration to SSH into my Maven server. So once I SSH into my Maven server, all I need to do is to cd into practice project, or well, let me do an ls so we can see we already set up the Maven project. So we have the practice Maven learning project. If I cd into the practice Maven learning project, I should see, and I do an ls, I should see the different code base. This is our project code base. I'll cd into the Java application code. If I do a tree, remember we installed tree on our Maven server. If I do a tree will give me a list of all the content of my repository. I have the source, which contains the main and the test, and of course we'll be doing the test on the Java application, on the demo application.java and the demo application test.java. So this is what we'll be running the test on. So for us to do the scan on this our code base, we come back to our SonarQube, we select the Java project, we copy this, and then we take it back to our code base. Remember, we are in our, if I do a pwd, you'll see we are in our practice Maven learning directory and in our Java code. So we'll paste that command here. Remember, I copied the command here from SonarQube and I paste the command here. So once you paste the command here, you hit enter. And now it will tell you scanning for projects. So this basically is running all the scans on your given Java project code base. So if it runs the building, the Java web app, and basically this is SonarQube scanning your entire project code base. Is running the various scan on your project code base, is doing Java class path, and equally developers equally injected a test. So once you do that configuration, you will see we have a build success. Now if you have a build success, they say more about the report processing at this. So you need to come back to your web, so you need to go back to your SonarQube server on your console to have more information on the scanning result. So I'll come back here. You see automatically it has put here that our passed, or you put here automatically that our Java web app has passed. So if you come, you see we have 0 bugs based on the code base we submitted. We have 0 vulnerabilities. We have 1 security hotspot. If you can come to security hotspot, you see what exactly that security hotspot is. They say you have, make sure that the command line arguments are used safely here. This is the security hotspot. They tell you that using command line arguments is security sensitive. It has led in the past to the following vulnerabilities. These are some vulnerabilities that this particular security threat is giving us with respect to the code base which we submitted. Now, if you come to are you at risk, they say are you at risk? So they tell you that if you do public class main, the role raises an issue as soon as there is a reference to argv. These are all Java-based programming configuration, so you don't necessarily need to understand this. So this is the ask. These are the sensitive code example. This is what we have as sensitive code, and then now they give you how you can fix that code. If you have to fix the code, this is how you fix the code. We are not developers, Java developers, so this will be most usable for a Java developer. And then they give you how can you fix the code here, so you can check out these documentations to fix the code. Now basically we've been able to run the scan on our project. And then you see the snapshot. This is when the snapshot was done, and you can see duplicated lines. We have 0% duplication. Now let's go ahead to inject some vulnerability in our code and then push to our repository and run the scan again. So I'll come back to my VS code containing my project code base. This is practice Maven learning project. We already had our practice Maven learning project. I'll click on Java application code. I want to modify our Java application code, the main code that we are using to run the project. I'll click on SRC. Under SRC is where you store the source code. I'll click on main, and under main I'll click on Java. Now we can have the main. Remember, we have the main which contains the main code and the test which has the unit tests. So I'll click on main, and under main we have our demo Java application. So I'll click on this demo Java application. So this is basically the application which we are running. This is the basic code that we are running for our application. We have this running as far as our application is concerned. Now for us to inject some form of vulnerability, I'll be adding some username and password to my code. Of course, it's not best practice, so let me add a username and password to my code. So I'll type string, and then I'll say I'm adding a database password, DB password. This can signify some password of some database in my environment. So I'll give the password admin123 or admin at 1234, and then I'll close this. So for you to perform the test, you just need to add this string on line 11, so you give string database password db password is equals to this. Now this is basically you modifying your code base. If you look at our GitHub, it will tell us that we've modified our project code base. Now once you do this modification, you have to do a git add to add these new changes. You do a git commit to push these changes to our GitHub repository. So modified, you can say modified project code base. You hit enter, so it will tell you that we have committed one file change, one insertion. Now for us to do the last step, we are going to do a git push. So I'll do git push into the repository using my credentials. Once I do git push, you'll see it has successfully pushed to our practice Maven Learning repo. So if I come back to my GitHub, I'll go to my practice Maven Learning. So if you come back here to repositories, you see practice Maven Learning, and you will see updated now means that we have taken, if you look here, our project, Java application project, we've done some new upgrades. Now the next step is for us to come back to our server, our Maven server, which has our application code base. I'll clear, and then I'll do a git pull. We are doing a git pull because we have made new changes to our application code base here. Because we have done new changes to our application code base, we'll do a git pull over here. So if I do a git pull and I hit enter, it will tell you this, it has actually pulled the new changes, one file change and one new insertion. So based on this new change, we are now going to rerun the analysis on the new code base which we have. So I'll come back to my SonarQube server. And I'll copy the, well, like I said, we've actually lost that configuration. That's why I said we should copy. We've already lost the configuration. That's why I said we should copy it and store in our rough.txt. So I'll come back to my rough.txt, still in my VS Code. I'll copy this configuration command which I had. I'll come back to my Maven server, and then I paste the command. This is the basic command we had to run the static code analysis or the SonarQube analysis on our server. So once I paste that and I hit enter, again it will run the analysis on our code base. And if there are no vulnerabilities, it will update us if there are vulnerabilities, or if there are no vulnerabilities in our code base. So SonarQube is running the coding analysis on the code base. Remember, we've been able to modify our Java code base by adding some database password, and then we've pushed it to our repository. Now the build is complete. So for us to check if our analysis was successful or not, we can refresh here. And if you refresh, you'll see that your analysis failed. You'll see your analysis failed. They'll tell you new security hotspot has been detected. Now, for us to know the security hotspot, you can click here on security hotspots. They'll tell you what the security issue is. So they tell you automatically that we have password detected in this expression. Review this potentially hard-coded credential. So if a developer randomly puts some password in his code, you as a lead developer or you as a lead DevOps engineer, you don't need to go into their code, the entire code base, to detect if there was a password that was exposed. The moment you run a SonarQube analysis, you automatically check the code base to see if there was some form of a password that was exposed. And in this case, they will tell us a password has been exposed. And you see on line 11 in the code base, it tells you, if you look at this path here, src main java com example demo java app, this corresponds to our same path. If I was to copy the relative path here, I'll copy the path and I paste here. If I copy this path, let me take away this respect to, let me just start from the practice Maven Learning. So if you look at it from the practice Maven Learning, you'll see the path here is practice Maven Learning java src main java.com. If you come to our analysis here, is the same path, src main java com, saying that you have exposed some password. Now they'll tell you these are some particular risks based on, so you see in the past it has led to the following vulnerabilities. If you open this in a new tab, you'll see some of the vulnerabilities which exposing a password like this has led to. So if you come here, you can continue to cite, and they'll give you more details about this particular vulnerability. So this is more details about that particular vulnerability. Now, if you come back to our SonarQube server, they ask, are you at risk? Are you at risk? So sensitive code example. This is an example of having a sensitive code where you have your credentials exposed. Now they ask, how can you fix this? For you to fix this, you can use this expression where you pass your username and password as secret. So based on this, if you come to overview, our pipeline or our analysis failed because we had some form of password exposed. For us to still test, we can come back to our code base. We come back to our code base here. Let me delete this. This is not important. Let's comment out this line 11. So you can put a 2 / to comment out line 11. You do a git status. Let me clear. You do a git status. You will see we have modified this Java code, src made, and all of that. So we do a git add, and then we can do a git commit -m updated code base, and then we can now git commit. Oh, I didn't spell commit right, so we do git commit -m git commit, and then now we do the last command, which is for us to do a git push. So I'll do a git push. Once I do a git push, I'll come back to my code base. So let me clear this. Once I do a git push, I come back to my code base and I do a git pull to pull the new changes I've copied, or I've put the new changes into my code base. Once I pull the new changes into my code base, I'll copy the rough.txt. Once I copy the rough.txt, so I'll run the rough.txt here, running the code analysis again. Now, the code analysis we are doing this time, if you take note, in our demo Java app, we've commented out this password which we exposed. Once we've commented out this password which we've exposed, we've copied our rough.txt. In our rough.txt, we've copied the scanning code. Once we comment out this, we push the new code into our project code base on GitHub. We do a git pull in our Maven server, and then now we are now going to copy this SonarQube analysis code, and we run the analysis, which we already did. So you see there was a build success, and once your analysis has a build success, if you come back to our code base, previously it failed. Why did it fail? It failed because we exposed some form of a password. But if you now come back to your code base and you do an overview, you will now see that it has passed because we've been able to, if you come to security, this is the only security we have is not related to the password. We've already taken away the password security vulnerability. So that's basically how you can use SonarQube to perform static code analysis on your given Java web application. See you in my next video.